The last symmetry operation which I want to introduce here is number 5, the so-called rotary reflection. The symbol what we are using for this one is SN. And you can already guess just by reading the name what rotary reflection might mean. It means that first you rotate around 2 pi over n, and second you do in reflection. Second you reflect. Again, let's take a look at an example. So in this case, I want to use proper diene. So proper diene looks like that. It has 2 double bonds. And remember from organic chemistry, if you draw lines, this means that the atoms are within the plane I'm drawing them, versus if you use arrows like that, this means that the atom here, in this case hydrogen, is pointing towards you, versus if you use this one, it means it's pointing away from you. So this just should illustrate a 3-dimensional structure here. So and also here I want to give it some indices. So let's say this one is hydrogen number 1, hydrogen number 2, number 3, and hydrogen number 4. What I want to do here first is I want to rotate this molecule by an angle of 90 degrees. Now remember our little formula, 2 pi over n, and n in this case is pi over 2, which gives 4, meaning what we want to do here is a C4 rotation. Now let's find our rotation axis first. We already put the molecule in the right orientation so that the highest rotation axis is pointing in vertical direction, and now we rotate the molecule by 90 degrees, which is pi over 2. What happens if we do that? Let's draw our carbon backbone of this molecule again, because this is our rotation axis, so nothing changes here. But what changes with the hydrogen atoms? Now this hydrogen atom here, when you rotate it by 90 degrees, moves out of the plane. It moves towards you, meaning we need to draw it with an arrow which indicates that. So this hydrogen atom number 1 is now pointing towards you, and this hydrogen atom number 2 is now suddenly pointing away from you. Hydrogen atom number 3, after you do this rotation, is pointing to the right side, because remember, originally it was pointing towards you, and if you do a 90-degree rotation, you just move it to the right. And hydrogen atom number 4 is moving to your left side. Okay. This was the first step. Now the second step is to do a reflection. Now also here, let's think about where we see a reflection plane in this molecule. So in this case, it's a reflection around a horizontal mirror plane called a sigma h, and this h stands for horizontal. Let's see what happens to the molecule after we apply this symmetry operation. Again, let's draw the carbon backbone of this molecule. And then what happens to our hydrogen atoms? Now hydrogen 4 moves all the way up after we apply this reflection. So hydrogen 4 will now be here. And it is in the plane because it was before in the plane. And same for hydrogen atom number 3, it is still in plane. Hydrogen atom number 1 moves all the way down. It was pointing towards us, and it's also pointing towards us after we do the reflection. And similar for hydrogen atom number 2, it was pointing away from us, and now it's also pointing away from us, but it goes all the way down here. And what we did, you can see here, we just moved this one down here and the other one up here, but considered that whatever was in plane remains in plane, and whatever was out of plane remains out of plane. If you go from this molecule to this molecule, right away, how you would call it is a so-called rotary reflection, and in this case it's a S4 rotary reflection, because first we rotated around 90 degrees and then we did a reflection. And you see that this molecule looks exactly the same like the one what we have here all the way to the left side, meaning these hydrogen atoms are in plane, those ones are out of plane, and they're exactly how this initial molecule looked like.